we had a little problem there. And what I want to do today is have a look at arcs. I don't know what you want me to do. No, I can't understand. What do you want? You want me to look at that camera? Yeah, okay. It's right, lots of chaos there to start with. Right, what I want to do is have a look at arcs and sectors. So let's have a look. Let's start with looking at what we want if we want an arc or a sector. So we start with the centre of the circle, and let's just take a little bit of a circle to have a look at. And this we can use as the arc length here, the length of a particular arc. Now, to do this, what we've got to know is something about this angle here, and we'll call it X because I don't know what it is. And this angle X that we've got here is going to be so many 360ths. It's so much of a circle, so it's going to be X over 360. And then if I want to work out the length of here, this is the circumference, so we can use the circumference, which is times 2 pi r. If we don't have that, then we could use pi d. Now, that works out the arc length. And instead, what we can do, we can use this to find, perhaps doing the same thing, let's just give ourselves a different one. And maybe what I want to do here is I want to find out perhaps the area of this chunk, and we're going to call this a segment, and that's going to be, well, we need to know again the angle X out of our 360, so that would be X divided by 360 times, this time we're working at the area, so it's going to be here pi r squared, and this gives me the area of my particular arc, but we'll call that the area of a sector. And so we've got these two for finding out either this length, the length of the arc, which is a fraction of a circumference, or we can use it to work out the area of a sector, which is a fraction of a complete circle. So we get various different problems we can do to try and solve some of these. So let's have a look at some of these. So you might get a problem where you've got something like this, and we've got a chunk of a circle, and here we're asked to find the arc length. What are we told? Well, we might be told that this is 8 centimeters, and we might be told this is something like 25 degrees, and so we have to work out what we've got. So this is going to be 25 over our complete circle, which is 360, and because we're working out the arc length, then it's going to be 2 times pi times my radius, which is here 8 And so all we need to do is put that into a circle, into a calculator, both begin with C, and work it out. So let's see if we can do that. So I like using fractions because they are quite easy things to use. So that's going to be 20 over 360 multiplied by 2 multiplied by pi and multiplied by my radius, which is 8, and it comes out as 10 over 9 pi, and that we can convert to a number which we get as a length 3.49, which is going to approximate here to 3.5. And there's our answer. Now, sometimes they put you off and they give you one that looks nearly right. But of course, it's designed to try and put you off. It looks like, from what I remember, a Pac-Man here. And this time they give you an angle. And let's say this angle is 50 degrees. And we might have a length here, which is 11. And we're asked to work out the arc length from A all the way around here to B. So I want the arc length of A to B. It isn't this 50 degrees, it's going to be the rest. So first of all, what we need to do is take our 360 degrees and take away our 50. That's going to give me my 310 over 360, because it's now the same sum as it was before, times 2 times pi times, this time, 11. So we can pop over to the calculator and we can work this one out. 310 over 360 multiplied by 2 multiplied by pi and multiply, oops, it didn't work, did it? Multiplied by 2 multiplied by pi and multiplied by the length, which is 11. 341 over 18 pi, not much help, but that gives us, when we come in here, the answer, which is 59.51, which will round here to 59.5 centimeters. And so we've worked out the arc length. It really was the same as the other one, but we had just an extra stage in there because we were looking for not the 50 but the rest. Now there are those. We can do the same, but this time we can look at area. So let's have a look at area of some sectors. And to look at the area of a sector, we would be given, perhaps in the same way, some sort of diagram like this, and we'll choose an angle. Let's say we get 42 degrees, and this is going to be 3.6 centimeters, and we're asked this time to work out the area of a sector. So first of all we work out how much 42 is of the whole circle, and then we work out the area of a circle using pi times r squared, which is here 3.6 squared. And all that we have to do now is to go and put this into the calculator and work out what we've got. So let's do that. 42 over 360. I'll try to remember to hit the arrow button this time, times by pi times by r, which is 3.6 all squared. And we come out here with our answer of 4.75 centimetre squared. We can have, as we did with the other one, this round the other way. And in this one we're going to work out the area of this piece here, and we might be told that this is going to be, you know, 84 degrees, and we're told we've got a length here. Let's have this at 15 centimeters. To start with then, we need to do our 360 minus our 84. So if we do that, it's going to be 360 minus 84, which gives me 276 over 360 multiplied by pi r squared, so it's going to be pi times the radius, which we've given 15 squared. And all we need to do is put that into the calculator. So I've already got my number there, so it's going to be that, which is my answer, divided by 360 multiplied by simply pi r squared. And my radius being 15 squared comes out at 345 over 2 pi, and that we translate as 541.92, and that's going to come out really at about 542 centimetres squared. And there we've worked out the area of those. A favourite question is to try and do a few other things in there, and let's just take another arc. And for this being worth 6 centimeters and this is worth 75 degrees, we're asked to work out not the arc length, but can we work out here the perimeter of the sector. The perimeter of the sector is going to be the arc length, which we work out in exactly the same way, plus we want to have this distance here twice. So we go all the way around. So let's work out first of all the arc lengths. So my arc length is going to be how much this is of the whole circle, so 75 over 360 times 2 times pi times r, which is going to be 6, and then to that answer we're then going to add on 6 and another 6. So we've gone here, around there, along there, and up again. So let's do this on the calculator. So we've got 75 over 360, then that's times by 2 times pi times 6, and that's going to give me 5 over 2 pi, and to that we're now going to add on 12, 6 plus 6, and that gives me an answer of 19.85 centimeters. So with all of these things we can have more complex little problems, but basically they come down to just trying to work out these simple things like the area of an arc or area of a segment. So let's look at a particular problem, and a favourite would be one that looks something like this. Let's go and put in my centre of my circle, and having got the centre of my circle okay, we have this sort of problem. Now, here is my problem that we've got to work out perhaps the area of this. So let's work out the area of this path, and also let's work out the perimeter. Of the path. So let's have some figures in here that make it sensible. So let's have that as 3 meters across, that distance there, and we'll have this distance here of 7 meters, and we're told that this angle is 110. Whether it is on my picture or not is irrelevant. So what we've got to do is work out the area and the perimeter. We'll work out the area first, and this is going to be by working out the area of this sector, and then working out the area of the smaller sector and taking them away from one another. So let's work out first of all the area of the large sector. The area of the large sector is simply going to be 110 over 360 multiplied by, to work out the area, it's going to be pi times r squared, and r here is going to be 3 plus 7, which is 10 squared. And that's going to give me my answer for the area of the very big sector. And from that we're going to take away the area of the smaller sector. And the area of my smaller sector is still going to be 110 over 360 times pi times, this time, 7 squared. And then we can take them away to work out the area of the path. Let's do that on the calculator. We've got 110 over 360, and then that is going to be multiplied by pi and multiplied by 10 squared, and that gives me this answer. Now I'm going to need that one, so what I'm going to do is I'm going to store that in memory A, and that number for my advice here is 95.99. I'm not going to round this number yet, because we'll round it when we've finished. Let's go and do the other calculation, which isn't really very difficult. I've lost the camera, so we'll see what we can do with that in a sec. Right, let's have a look and see what we can do. 110. Let's go to the calculator. Let's cancel that and we'll deal with this one. So we've got 110 divided by 360 multiplied by pi, and we've multiplied that by, this time, 7 squared, and that gets the answer of 539. And what I can do is we'll just work out what that is, and that is, on my calculator, 4703. I'm not going to round this, and so the area of my path is going to be the large number, 95.99 minus 47.03, and then what we're going to do is take them away. So let's do that on the calculator. So all I want to do here is recall the numbers. So let's cancel, and what I want to do is I want to recall memory A, and from that I'm going to take away what was in memory B, so I'm just going to shift recall memory B, and that gives me 187 over 12 pi, or in real numbers that's going to give me 48.95, and we're told it's meters, so it's meters squared. If we want to work out the perimeter, then we need to do this in the same way. So let's try this one out. To do this, then I want to use that same information but this time we're going to work out first of all this arc length, then we're going to work out that arc length, and then we're going to add on 3 here and 3 there. So let's do this. So we're going to work out first of all the arc length of the long side. This is going to be 110 because it's the same angle over 360, and this is going to be times 2 times pi times r, and r in this case is the distance of 7 plus the extra 3. We're going to take the other arc length, so we're going to also work out the arc length of the short side, that's still going to be the same amount of number there, 2 times pi times 7. And then what we're also going to do is to work out the perimeter, and that's going to be the long side plus the short side plus the width plus again the width. The width here we know is 3. I don't know those numbers because we haven't worked them out yet. So let's go and do that on the calculator. So let's work these out. So we've got 110 divided by 360, then multiply this by 2 times pi times 10 gives me an answer, and I'm going to store that in memory C, and then let's move on and do the other one. We're going to do 110 over 360 times by 2. I didn't press the button. Times by 2 times by pi, and this time times by 7. And that I'm going to store in memory D. I didn't pull those numbers out, but that's not going to be a problem for me. So here what I want to do is I want to recall memory C. That was at 19.1, so I can write that one down, and we can see D was 13.4. 14, sorry, yeah, 13.4. We've got those on the calculator, so I'm going to recall memory C plus I'm going to recall memory D, and then I'm going to add on 6, and it gives me my answer here, which is 38.63, and I could put those numbers in. And that gives me my answer, which is going to be approximately equal to here 38.6 meters. And we've managed to do that awkward sort of problem trying to work out the area of a path. One other favourite one that people get is to do another nasty little problem, and that is we have with our circle we have our sector, and then for some reason they've decided to draw a line down there, and they want perhaps the area or perimeter of this shaded piece, and we might be told that this is 8 centimeters, and we might be told that, let's be awkward, let's have this angle as 50 degrees. Now, if we look at this particular triangle, this distance here is a radius, this distance is a radius, so this is an isosceles triangle. So if I look at my isosceles triangle here, then if this is 50, this is 50, add them up, that's going to be 100, take away from 180, that tells us this angle is going to be 80, and that's going to be 8. Now, what we can do then is to work out various things to work out the area of this sector. So if I worked out the area of this sector, and then I work out the area of this triangle, then we might be able to work something out. So let's see what we can do. The area of the triangle is not really as easy as we would like, but there are a variety of ways of working it out. So first of all, let's work out the area of the sector. We've got 80 degrees over 360, and this is going to multiply to work out the area by pi r squared times 8 squared. So there is our area of our sector. Let's work that one out. The area of our sector is simply then 80 over 360. Remember to press that one, multiplied by pi, I didn't want that, multiplied by pi times r squared. 128 over 9 pi, and that's going to give me that number, and that I'm going to want, and so I can store that in a memory. So I'm just going to store that in memory E, and there is my number, 44.68. Now, how to go about working this? There are basically two ways of trying to do this. One way is to try and use sort of Pythagoras and try to sort of work out various things of this circle, but if you're given something like this, then we're probably going to use something to do with the area of a triangle using the area of triangle equals my formula for doing this, which is a half AB sine C. I've got those two as 8, I've got that as 80, so we can do that. So it's going to be a half times 8 times 8 times the sine of 80. Let's see if we can work this one out. I've stored that already, so it's in answer E, so I can clear that, and we can work out this as being a half, I'm going to put it in as 0.5, times 8, in this case squared, times the sine of 80. And that comes out with an area of 31.51. I'm going to pop that in my other memory, which I haven't used now, which is F. So I'm just going to store that in memory F. I want to take my area of my sector, and my sector I stored in memory E. So I want to recall E, and I'm going to take away from that memory F. And there we have it. We're going to have 44.68 minus 31.51. These are only approximate numbers, giving me 13.1665 whatever, and that's going to give me here 13.2 for my area. So we can work out various things with this. If we also wanted to, we could also work out the length here, and if we work out the length there, then we can work out the perimeter of this sector. To work out then the perimeter of the sector, what I would want to do is first of all work out that length. That's the arc length, which is going to be here 80 over 360 multiplied by 2 times pi times r, and that was 8. So that's relatively straightforward. Now I want to work out how long that side is going to be, and for that I'm going to need to use a little bit of trigonometry to try and do this. Now, what do we know? Well, I'm going to use the sine rule. To work out the length of the longest side. So if I'm working out a side, then I'm going to put here 8 over the sine of 50 is going to equal a bit I don't know. I'll call that A, and that's going to be A over the sine of 80. Put my brackets in, rearrange this, so 8 times the sine of 80 over the sine of 50. This is not the only way of doing things. Sometimes they work things out so you can do them other ways, but in this case we're going to do it this way. So to work this one out, let's work out first of all the perimeter of the sector. So my perimeter of my sector is going to be 80 over 360 multiplied by 2 multiplied by pi and multiply that by 8, 32 over 9, and I'm going to store that. I've used all my memories up, so it's not a problem. I can store that in memory A, and it will just overwrite the memory. And if I just have a look at that, that's 11.17, so I can write that down. Let's now work out this one to work out the length, which is going to be the sine rule, which is going to be 8 times the sine of 80 divided by the sine of 50. I didn't do this one as a fraction, I just did this one differently. And that comes out at 10.28. To work out this distance, we're going to need to go along this straight line and round there. So it's going to be adding those two together. So the perimeter here is going to equal my 10.28 plus my 11.17, and that on the calculator is going to be that, plus I'm going to recall, we put it into memory A.
Here's your reminder. Take a break in tablets.
Not very helpful. So let's just finish that one off. 10.8 plus 11.17, which is memory A, gives me here 21.454, so it's going to stay like that, centimetres. And we've worked out here the perimeter. When we talk about some of these shapes, basically we can come up with a whole variety of different bits and pieces. We can try all sorts of interesting shapes to sort of play around with, and we get a whole variety of these. I'm not going to do some of these, I'm just going to introduce you to a couple of them that we've done. Some of the basic shapes. Some of the ones that I've seen that aren't particularly nice are when we can take things like a shape like that one, put this one with there, and put that there to try and work out irregular sort of shapes to try and work out. And then with shapes like this, you might need to work out the area of this shape, and this gives you a bit of a problem trying to sort of work it out, but it's not really quite as difficult as it seems, because we have to try and work out where everything goes, and we have to sort of know a few sort of angles about where bits and pieces go. And if I draw in the center one here, we can see there's going to be a triangle there, and we can work out perhaps what some of these angles are going to be, so that we can work out everything. Another nasty one that I've seen is where we take some sort of circle. I'm just going to draw it out here very badly. This is an arc of some sort, and inside that they put another arc. Of some sort. And you then have to work out the area of this arc and the area of that one and take them away from one another. So they're not too difficult to try and do. Other ones where we have funny shaped tables, so I've got myself a nice rectangular table like that, and someone decides to put onto that, I'll try a better circle, some sort of art table, not well drawn, and you have to work out then perhaps the area of the whole thing. And again, that's just going to be working out the area of this and then working out the area of this sector. So sectors and arcs aren't particularly difficult ways of trying to do things. They just use this same sort of formula each time, and as long as you follow those through, then they work out quite simply. If you like this, then please subscribe and like, and I will see you next week when we'll do some more GCSE Maths topic by topic. Until then, stay safe. Bye bye.